morning to all. I am Dr. M. V. Dandapani from Mech Design Consultancy, Coimbatore. So, I welcome you all for the one-day seminar on the topic of designing, drafting with GD&T as per ASME standard Y14.5. So before going to discussing about the core topics, first of all I will give a brief idea about what exactly the design engineer's requirement, because nowadays the industry will be expecting there are many parameters how to read the drawing, how to study the drawings and detailings like bill of material, and how to select the materials and standards. Apart from this, the basic and fundamental calculations and how to define the GD&T symbols and dimensions with respect to the drawing what we are using in an industry. So these are all the basic parameters is required while entering into the design engineers in an industry. As a design engineer, to know the basic and fundamental concept about the units and formulas and bending and torsion equations for calculating the stress and deformations. The sheet metal or surfacing, standard formulas and standards may be used in an industry scenario. Okay, so once these basic concepts if they are studied, then they have to apply by using the softwares. There are many softwares which is available like 2D software, 3D CAD software and CAE simulation or analysis softwares. So in my opinion is design engineers or R&D mechanical engineers should know the two-dimensional softwares like AutoCAD and 3D softwares like SolidWorks or Creo or CATIA, something like that. Once if you know these two softwares, you get an idea about how to draw the drawings, how to incorporate the drawings with respect to the softwares. Okay, so if he will get an experience maybe 1 or 2 years, after that he should learn CAE softwares, maybe ANSYS or Hypermesh and CFD also. Okay, if we know these concepts with their finite element method applications, especially theoretical point of view, then definitely he will achieve like whatever he want in an industry. Okay, so this is the basic and fundamental concept about the design engineer is required for an industry. Good morning to all. Today I would like to share with you regarding the topic of GD&T. Present scenario, the industry will be expecting the more aspect of GD&T, but as a design engineer, before going to get the skill or the knowledge about GD&T, first of all he should know the basic and fundamental concept about what exactly the meaning of drawing, designing, detailings. Okay, so in any engineering industry we should know the concept of engineering design, and once should get an idea about the product, like the concept of the product, and should do the drawings. So for that drawings, the detailing about title block, bill of material, layout and other parameters is much more important. And when the drawing, if you are going to do that, in global level, there are two types of angle of projection used. One is for first angle projection and third angle projections. And there are some basic parameters like dimensions, detailings and isometric view orthographic projections and surface development, section of solids and all those things. We should know the selection of materials and their properties, basic heat treatment process and the standards and standard component, basic mechanics, how to select the channels and the structures, the standard components like the bolt, washer or nut, circlip, all those things. How we have to select it, what the basic size and what is meant by pitch. So based on that only we have to select the basic component. Most important parameter like power transmitting device like gears. So how to do the gear design. Okay, so there are many parameters to do the designs. So that is also another important factor. And design of casting and machining components and the sheet metal design. These are all the important content or important parameters which is required for a design engineers. I'll discuss about the GD&T. So what is meant by GD&T? GD&T is nothing but geometric dimensioning and tolerance. Any manufacturing drawing or any production drawing, if you are going to manufacture the product, so we should define the dimensional details and tolerances by using GD&T concepts. This GD&T concept, it is arrived from the ASME standard Y14.5, because the current scenario, the American Society for Mechanical Engineers is released Y14.5 version. So with respect to that concept only, we should apply the like basic symbols, tolerances and datum planes in that particular production drawings. In this drawing, we should mention by using feature control frame. The feature control frame is much more important to specify the GD&T concept. Yeah, this is GD&T. Generally, in design department should know the design, tooling, production and inspection. Once this portion is completed, then the product will go for assembly. So some set of symbols is required for specify the like the GD&T concepts, like maybe circularity, runout, total runout, and angularity, perpendicularity, something. Okay, for example, if you take a simple structure, angle block. So this angle block, which consists of these linear dimensions as well as the angular dimension and cylindrical dimensions also. So here you have to specify. You just see that there is a simple structure. In the structure, we have to specify the linear dimensions all within the box, within the rectangular box. It's a whole dimensions, right? So as per GD&T, you should specify all the linear dimensions should be within the box. If you see the circle here, and the diameter of the circle is specified here, and the tolerance also specified. If you want to represent the GD&T symbol concept, here it's mentioned this position symbol. Position symbol with the diametrical tolerances and maximum material condition symbol. Then we have three symbols called like primary, secondary and third datum plates. Okay, and here you just see that one of the profile which is represented like this is called as surface profile. In that surface profile is also consists of tolerances and datum plate. See, we have the industry like maybe R&D department, production department and inspection department. So in that particular GD&T concept is required for all the three departments, because see, drawing is going to make by using R&D department, and the drawing will be released, then that will go to the production department for manufacturing the product, and again the same drawing should be go for inspection department. So mainly for making the drawing by using R&D design concepts, then that will be released to the manufacturing department. They could see the dimensions and the basic parameters, how to manufacture by using basic production process. Once if that part is completed, the product should be dispatched to the inspection department. So what the inspection department is going to do that, here they are going to use some measuring devices like dial gauges or vernier caliper, height gauge or depth gauge, whatever it is. They are using those devices and they are going to check the dimensional parameters for the manufactured component. Right? Drawing which is available in the GD&T concepts and dimensions, it should be matched with the product. So by using the inspection, they should validate whether the correct dimensions are there or not and tolerances are exactly specified or not. So that is the core concept of all the three departments should be integrated for design. Okay, good afternoon. I would like to share with you the GD&T and its basic symbols and how the applications of GD&T used. The basic symbols like form and profile symbols, maybe the flatness, straightness, circularity and cylindricity. Apart from this, profiles may be line profile and surface profile, type of tolerance like orientation tolerance and run out locations. It's like orientations may be perpendicularity, angularity and parallelism, and runouts may be circular runout and total runout. Then the location may be concentricity, position tolerance and symmetry. So these are all the basic GD&T symbols used in an industries. Symbols like modifying symbols. See the maximum material condition and least material conditions. These are all within the circle we have to represent capital M and L like that, and projected tolerance zone, free state, radius, diameter, and all those things. See here we have to see that there are three drawings it is there. One is for drawing and its representation. Rectangular plate with the hole. So we have front view and side view. Here the representation should be flatness and the tolerance should be 0.002. So as an R&D engineer should specify the drawing like this and release to the production department and quality control department. So in production, how they are going to manufacturing. So as per the dimension and with respect to the tolerance they are going to manufacturing, and the tolerance zone should be specified within the limits like 0.002 tolerance zone, the size. Actual dimension, maybe you can assume it as this height should be 100 mm and the flatness may be 150 or 200 mm. So what will happen? If you want to specify the flatness, it should be the accurate dimension of the height. Accurate dimension of the height. So the height with the tolerance we have to specify. After completion of manufacturing, the product should go to the inspection department or inspection or quality control section. So in quality control section, they are using the manufactured component with the measuring devices. Like maybe here in this representation, just see that there is a dial gauge. So the dial gauge should be fixed on the flat surfaces, and the component should be located with respect to the dial gauge where it is provided, and by using the dial gauge where the flatness should be maintained. So those location you can move either the forward direction or backward direction. We should maintain the tolerance within the limit like 0.002, maybe a plus side or the minus side. Okay, so this is how they are measuring the dimension. If the product should be within the limit, within the like a tolerance limit, then the product should be accepted and it will go for dispatching, right? If suppose the product maybe it's failed, then again we need to do the modification of the product, or otherwise that will go to the scrap. So this is how the symbol should be used and produced by manufacturing, and after manufacturing the testing will be happen. See, this is another important symbol which is used in the production drawing. Cylindricity and circularity, and also for the runout and total runout. These are all the symbols which is comes under where we are going to use the circular components. There are many symbols are there, especially here we are using the circularity symbol for finding out the specific tolerance, and here the representation is mentioned circularity with the tolerance. So as per the tolerance specification with the GD&T symbol, we have to manufacture. After manufacturing, inspection method, we have to use the flat plate to hold the component to check the within the limited dimension by using dial gauge. So after completion of that, then we have to segregate whether it is accepted or rejecting the component. There are many symbols and representations are there to determine by using GD&T symbols to finding out the tolerances. As per the tolerance, make the drawing and go for manufacturing, then finally testing the component. Then finally you will get the best product of meeting the market availability. Okay, thank you.